Well, the good news is that you don't really need knowledge of mathematics to be a good programmer. You can be a good programmer without knowing good mathematics. But the thing there is that you need some bit of mathematics to be a very good programmer. And that mathematics is called binary arithmetic, binary conversion, and binary bitwise operation, because this is what you're actually going to meet in your programming. So is it difficult? No, it is really easy, and I'm going to teach you this today. Remember to subscribe to my channel. Click on the subscribe button below this video to subscribe to my channel so that you kind of motivate me to continue to make this lesson for you. And also you get updates when I make new lessons in this channel. Also, if you have any challenge following my lessons, just leave a comment below, let me know, and I'm going to get back to you immediately to clarify whatever challenges you have. So just subscribe to my channel so that you get notified when I make new lessons. So let's start with the first one, binary arithmetic. Right, so the key to binary arithmetic, because the three of them, they all have keys. So the key to binary arithmetic, I'm going to write it out for you. So if you remember this key every time, then you get exactly how it works perfectly. So the key is that 1 plus 1 is equal to 10. I have 1 plus 1 plus 1 plus 1 plus 1 is equal to 11. So this binary arithmetic, we are going to also meet it a bit in binary conversion. But now let's take an example. If we have a is equal to 1, 0, 1, 1, 0, 1, 1, 0. I'll have b is equal to 1, 1, 0, 1, 1, 0, 1, 1, right? So let's carry out addition on this. Let's carry out, I'm writing this way, okay. And also take note that in binary arithmetic, you only have plus and minus. You don't normally have multiplication and division. So you have plus and minus and no multiplication and division. And if you know how to do the plus and minus, you are okay. So take note of this key as we move along. So let's start. 0 plus 1 is 1. 1 plus 1 is what? Is 10. So we have to write 0. And then we have 1 move across, right? Good. So 1 plus 0, 1, plus the 1 we already have is 10. So we write 0 and we have 10. We have another 1 moving across. We have the same thing here. 1 plus 0 is 1, right? Plus 1 that we moved across, it gives us 10. So it means we are going to write another 0. Now here comes the thing. 1 plus 1 is 10 plus 1, so 11, right? Good. So that is quite easy. So in this case, we are going to write 1 and move 1 across. So the same thing comes here. 1 plus 0 is 0 plus 1. We have 10. So we write 0 and move 1 across. 1 plus 0 is 1. Plus the 1 we moved across, we have 10. So we have 0 and we have 1 move across. 1 plus 1 is 10 plus 1 is 11. So we are going to write it. So this will be the result. So take some time to get your head around it. And now we are going to try our hands in minus. So if C is equal to 1, 0, 1, 1, and D is equal to 0, 1, 0, 1, let's do a subtraction to say 1 minus 1 is what? Is 0. 1 minus 0 is 1. 0 minus 1 is what? 0 minus 1, it doesn't work. So we take 1 and put it here, it becomes what? 10. Remember, 10 is 1 plus 1. So if we take out 1 from here, so we have 0 here, we can simply write it as 10. Right? Good. Or you can simply write it 0 carry 1, and then when you move it across, it becomes 1. So I hope you got it. So this is basically binary arithmetic, and this is the key. Once you know this key, everything is okay. So I'm going to now move to the next one, and that is binary conversion. All right, let me pick up my pen again. oh sorry, this is, so binary conversion means you need to convert from binary to decimal, or from decimal to binary. So decimal is numbers of 0 to 9, and binary is number of 0 and 1. Good. So how do you do this conversion? I'm also going to give you a key. The key is this, is to have a line of numbers of the power of 2. 1, 2, 4, 8, 16, 32, 64, and so on. Now, this very one is 2 to power 0. This is 2 to power 1. This is 2 to power 2. This is 2 to power 3. This is 2 to power 4. This is 2 to power 5. And this is 2 to power 6. And it continues in this way. We have 2 to power 7, and it continues. So let's take examples. We have if a is equal to 20 or 12, let's convert it to binary. And binary is the same thing as base 2. So when you are given a number to convert from decimal to binary, you come here to check. So what is 12? 12 is 4, because you check where 12 belongs in this place. So where does 12 fall? 12 falls in between 8 and 16, somewhere here, right? So 12 falls somewhere in between these two, meaning that you need to put 1 in this place. So the first step, check in the timeline or in the binary line where 12 falls and check where it belongs. So put 1 there. The next thing you want to do is to subtract 8 from 12, and what is left will be 4. Like 12, we've removed 8, so what is going to be left is 4. We check 4 and we have 4 here, so we put in 1. So when we remove 4, it becomes, what is left is 0. So 8 plus 4, we already have 12, so we complete it 0, 0. So this means 8 is equal to 12 is equal to 1100 in binary or in base 2. Let's take another example. Let's try to do 25. If b is equal to 25. So in the same way, you check where it belongs. It falls somewhere in between 32 and 16. So we have 1 here. So if we remove 16 from 25, what is going to be left should be about 9. So 9 falls in between 8 and 16, right? Good. So we take 1. What will be left? 8. 9 minus 8, 1 is going to be left. So we can't, it's not 4 because 1 falls around this place. So it's not here. So we have 1 because 1 is exactly. So if you have anything exactly the number, just write it under it. So in this case, we have 1 1 0 0 1 to base 2. Good. So normally, if you are given a binary number to convert, let's say, let me just show you how it's normally done in textbook. So if you are given 25, normally you now start dividing it with 2. So you have 2. You have what? 25 divided by 2. You have 12. Remainder what? Remainder 1 because you have 24. You have 2. Have what? 2 divided by 12. You have 6. Remainder 0. You have 2. You have 3. Remainder what? 0. You have 2. 3 divided by 2. You have 1. Remainder 1. And then 2 divided by 1, you have 0. Remainder 1. and then you take from down upwards, you have the same as from down upwards 1 1 1 1 0 0 1 0 0 1. So this is basically how it's done in textbook, which is actually the same thing here. Now if you are given a binary number to convert, how do you convert it? Now that is where it is a bit tricky. So the same thing is the same thing you want to do here. You want to check where they belong. So you simply start from the first part and then write it. After writing it, you now add. This you have 1 plus 0, all these are zeros, plus 8 plus 16. So you count the numbers here where you have 1 in the decimal. So let's take a simple one. 1 1 1. How do we convert it to decimal? So we simply write it 1 1 1 and add it 4 plus 2 plus 1, and that gives us 4 plus 2 is 8. 4 plus 2 is what? Is 6. 6 plus 1 is 7. So in the same way, if you are given any other number, let's say 1110, you simply write in the same way and then add the numbers where you have 1. In textbooks, what you have is this number corresponds to 0, this number corresponds to 1, 2, 3, and so on, and it moves on. So what in the textbook they will do is they will say you do 2 to the power 3 plus 0 times 2 to the power of 3 plus 1 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. So this is actually what is done in the textbook, which is actually the same thing we are doing here, but in more like a more formal way. So 0 times 2 to the power of 3 is 0 plus 1 times 2 to the power of 2. 2 to the power of 2 is 4, so we have 4. 1 times 2 to the power of 1 is 2 plus 1 times 2 to the power of 0 is 1, because anything to the power of 0 is 1, so plus 1. So you have exactly the same thing. We have 4 plus 2 plus 1, which is equal to 7. So try to use this method to do it, to choose some numbers and do it at random, and so that you get your head wrapped around binary operations. Meanwhile, so this is where we've been working before now. So sorry, I made a mistake. So this is so this is actually binary conversion that we did, not bitwise operation. We did not do bitwise operation. So what we did was conversion. Binary conversion. So let's now go to do bitwise operation. Sorry, give me a second. Okay, so let's now do bitwise operation. So bitwise operation is an interesting one. So if you have, let's just take an example. A is equal to 1 1 0 0, and we have this shift. This is what? This is shift right. Let me write it out. Shift right. And this is shift left. So it's called bitwise shift. So if you are now told to do A shift right 2, what it means is that you want to shift A to the right in two positions. So more like you are sliding it, assuming that this is a cliff, and you are throwing off 2 zeros. So what you have is some blank space and then 1 1. because you've already thrown away 2 zeros. And when you do a shift in that way, the space that is created is replaced by 0. So A shift right by 2 will be the same as, let me write it, 1100 shift right by 2 will be the same as 0011. So that is shift right. In the same way, shift left, if you have 10, let's say 10001, let's just say this. If we are doing a shift left by, let's say, 3, so we try to assume there is a cliff, and then we are throwing off there are three binary numbers, 1, 2, 3. In that way, what is going to be left here is 0, 1, because these three have shifted away. So what is left is 0. So the space that is created behind, we replace it by 0. I hope you are following. So if you have 0, 1, 0, 0, 0, 1, I have bitwise shift left 3 will give us what? 0, 1, 0, 0, 0. So this is how the shift works. Try to wrap your head around it, and then we continue in the next part. If you have any difficulty following it, please let me know in the comment box below, and I'll respond to you. I'd like to thank you for viewing, and also remind you to subscribe to my channel if you've not subscribed.